episode of FUM0078 machining. We are continuing the VFD modulator, speed modulator project. This time we are going to test the software I coded in there, and in addition I will introduce you to some of my measuring equipment. So I have already set it up in there, so let's go to my workbench. This here is my humble oscilloscope. It's a 4-channel Tektronix, and there is some dirt in the glass. Okay, so and it has served me really well. This one is not so very new, but it works. So the power switch is here, and we are currently using channel 1. Here is the probe, and we are using 0.2. We should be using 0.5. So half volts per division. It means that when here is the end of here is the probe, and if I connect, there should be a test output somewhere. There we have it. Put it there, so we can see. What we can see is that I could put it a little bit higher, and then the triggering. Okay, yeah, there you are. So it shows me voltage variations here. So okay, but this is what we are using to measure. This is the ground wire. Okay. This is my keyboard. It's a very old style of keyboard. It's an IBM. Has a very nice touch in it. I like this a lot. Well, IBM once upon a time made very good keyboards, really. And then I have this Linux powered machine under my desk. And then the monitor is there. Well, it's flickering, I believe. This is the programming environment, the computer environment. Then there comes a red wire up here, and we are doing the actual brain surgery here. This is the programming interface, as you remember. And then we have a power supply somewhere, comes to here. This is my adjustable power supply, which I made once upon a time as a temporary thing, but things seem to be not so temporary. I believe it's over 10 years old. Okay, so what was on the screen? So we had first of all my PCB software. This is Eagle, and this is the schematic of this thing, and there are the ports. I only need it at this point for looking which ports are used for which purpose. Okay. Then I have a text editor. And here we have a make file, which is actually just defining how to build this application. So first I of course tell that it's 80 mega. And then there are some library definitions, some tools, default build, and so on. This is a make file, which means it means that I'm building this total manually. I'm not using any type of IDE, integrated development environment. I don't use those, I don't like those. Well, make file. And then that's for the build utility. And then we have VFD modulator.ho. This is for definitions. And here we have the port definitions. For example, we have in port B, we have these 3 buttons. They are here in the side. There is a correspondence between all these things. And that's pretty much of it. Then we have the actual source code, which is at the moment just a stub. There will be some more. I probably will draw a block diagram for you. And then we have this command line utility here. And now we can actually try to program this. Let's see. This makes a cleanup. Let's make a cleanup. Yeah, cleanup done. Just make. Let's see what happens. This means now that it compiled the program, and program itself is at the moment about 600 bytes long. And it consumes 25 bytes of internal static RAM. Well, nothing much. So, okay. Then we have fuses. Fuses is a thing that you define on the microcontroller which type of crystal it is using. In this case, we don't use a crystal, we are using the internal oscillator. Well, it's actually defined in the make file. We have here somewhere, there we have it. There you have all fuses. Okay, we can make fuses which then tries to upload the data into the controller. Let's try that. Oh, there was an error. Access failed after 32 retries. Well, I knew it would happen because we didn't have any power. So let's adjust the power to 10 volts. 10. Try again. Ta-da! It's there. So the program is really working. Now let's do the programming itself. There, make program. Brain surgery done. Now the program is there and it's running. But it does nothing at all. So my next task will be to program, make the program. It's easier than you think, but it's still, I need to program it. Okay? So what we have here, wait a minute, I need to take something to point you things with. Okay, what here we have here is a multimeter, which is now set for 20 volts range. And then we have we have a power supply, which I now switch on. Then this multimeter is connected with this probe, which is really has a small needle there. This is very thin, so I can reach very thin surfaces. And now the first thing, I have adjusted this to 10 volts, but I want to be sure it's exactly. So therefore, let's measure the 10 volts. Again. This is always horrible. Volts. The ground wire. Aha! well, I need to connect the ground wire as well, because now we have better chance to get yeah, okay. Now we adjust it exactly to 10 volts, because I really need to be sure that we are, there we are, it's now 10 volts. Maybe you can see that 10 volts, it's upside down. Yeah. Okay, and then we have here what we have here additionally is this is the ground wire. This is the minus from power supply, plus from power supply. We just measured it's 10 volts, really. Yeah, really. Then this wire, this smaller wire here is, this is actually the output to the VFD speed control. It's analog output with from 0 to 10 volts. Well, it's not going to be 10 volts because we have here an operational amplifier, which is not a so-called rail-to-rail type. It will not output full 10 volts, it will be somewhat lower, maybe as much as 8.5 volts maximum. And then we have the microcontroller, which I have been programming. And then we have the potentiometers here, 3 couples of them. Oh yeah. And I have no idea which is connected to which. And then we have the oscilloscope. And now I'll put this a little bit here so we can put the oscilloscope somewhere around here in the corner. Okay, now let's put the oscilloscope on. The ground must be connected like that. And then we have the probe. We put it there, and now we should see something in the display. Well, it's rising there. Let's see if we can... oh, it's fluctuating. Let's put everything in minimum. So then we should have... one of these potentiometers should be impacting the... this is not the level. 0.5 volts. This should be going up to 10. Okay. 0.5 volts per division. Let's put it for 1 volt. Not that one, that one. Because now it's showing too little. Which one was it? That one. It's only showing 5 volts. Why? Let's see if I probe the 10 volts, if it's showing correctly. 10 volts is here. Ah! That's the reason. Now we have to adjust it so that the 10 volts is up there. Now. Well. Interesting. Anyway, now the 10 volts is up here. 0 volts is down there. Okay. And now we put this here. So we should be able to adjust it all the way. So now it's the lowest and now it's the highest value, and as you can see it's not the full 10 volts, it's a little bit under, maybe 1 volt under. So we adjust it to the middle, like there. Now its output is 5 volts. And now what we should be able to do with these potentiometers, one of these is the amount of fluctuation. Which one, actually? Not that one. Then it's this one. Yeah. So now, and this one is then the frequency of oh yeah. So I will put it a little bit. So now you can see it's going up and down. I can adjust the amount. Yeah, I can. Actually quite well. Well, so far this seems to be working. Haha. Okay. That's one. I think my software is working alright. Well, the tops are rounded, as you can see. This is because of the operational amplifier. I believe if I raise the voltage a little bit. Exactly. Now when I put it somewhere around 12 volts, well, now it goes all the way. But since we are having 10 volts, I'll check that it is 10. There you are. So since we are using 10 volts, we have to use it. So now, so far, so good. Okay. So now let's put this fluctuation away. And now what we are really interested in is actually we put the AC mode on. You can see there is a little symbol which now tells that it's AC. And now we put a little bit more sensitivity to that. Let's see what we have here. Well, we have some ripple. So it's 2 millivolts per division, but it's actually 4. Because, no, it's 1 millivolt per division, I believe. This calibration is probably not. Aha. Okay. Is it 20 or 2? It's 20 millivolts. So we can adjust the trigger a little bit. This is always a pain in the ass to adjust mode. There you are. So what we have here is some. This is remains from the PWM system. So we could measure it like that. Now it's telling us that is 0.7. So it's actually 700 hertz, this frequency here. Okay. How do you get this off? No. Okay, there. Well, too many features in the scope. So, this means that we have remains from. Let's put it again on the DC mode. Where is our... Oh, it's the triggering again. Where is it? Hello. Where is my trigger? Channel 1, level, nothing. Oh, I hate this oscilloscope actually, it's so smooth. Normal. Out. Where is it? Huh. Ah. Good. So there it is now. My intention was to measure the PVM actually, to show that one to you. So, it should be somewhere, and now I need my magnifying glasses because I don't see the PCB. Let's see now where it is. It should be in that point. There it is, actually. And as you can see, here we have the PVM. And I can adjust that one with this knob. And it works really nice. Yeah. And there are no glitches in that one. That's also a good sign. Normally when you make a software like this, you get a lot of glitches there. Well, I would say so far, let's just for the sake of it, let's see what happens if I, this is how it looks like in the output from the micro controller, and then we have the output to the is like that. So there is some filtering going on, and so far everything works all right. So that was this very short episode of Finogric machining. In the next episode we will be machining something. Actually, it's still the VFD speed modulator project, but we are going to machine a housing for this one. At the moment I don't have a suitable readily made housing for this one, so I need to make one. And I will make it quite robust, and it should be robust. After that we can put it in real life use, and then we can test whether it really can medicate chattering or is just an annoyance. Okay, till then, see you!